is a little bit different than what we did before. Okay, 7, 8, 9, 10, they're on something different. The main concept that we need to learn from fundamental 1 now is the AC power. Okay, it's the AC power plus the concept of the impedance. Okay, but the analysis is a little bit different than what we did, so now we're dealing with something different. So just an introduction to this, that the sources or power or whatever or circuits can be divided into three things, or two mainly. One is DC circuit. So you will have a DC voltage source, a DC current source, and usually in a steady state we only deal with resistors. Okay, and for me Ohm's law will be V equals to IR, or I equals to V over R. Okay, stuff like that. Then there is the AC circuit, and this is two type. One, in general, we call it single phase, and this is what we did so far. Okay, single phase, it means we have an AC source, the voltage source, sometimes it's current source, AC, sometimes you have an impedance, Z, and Ohm's law is V over V over Z. The current I is V over Z. Now we're gonna deal with something else. It's an AC, but not one phase, it's three phase. So the lectures 7, 8, 9, 10, they're three phase AC circuits. So you're gonna have three phase sources. You're gonna have three phase loads. You're gonna have three phase power, for example. And since it's AC, this one can be real, can be reactive, can be apparent power. Okay. So this is now what we're gonna work on. Three-phase circuits. The sources are three-phase, the loads are three-phase, what connects them together, how to do the analysis for this. Now question, very good question. What do you mean by phase? Okay. So this circuit is called single phase. Okay. So what do we mean here? We mean the voltage has one phase angle, and it's one voltage. Here, for example, E. The current will be one current with one phase angle in this loop anyhow. If you have different loops, then you still have one current in there, and so in every element in the circuit, you're gonna have one current, okay, and it has one phase angle. Phase angle is one, and source is one, and the load is one. Let's say this is the load. The load will have voltage with an angle and the current with an angle. Now three phase, it means you're gonna have three phase source, and we will see what that means. So three phase source. Load, it will be three-phase load, which is basically three single-phase loads. And here is a three single-phase sources. And in between, you're gonna have the wires, like this wire. Okay, maybe the wires has impedance as well. So this is called three-phase circuit. It means it has three of this, three loads connected together, three sources connected together. So if the word phase is confusing, this is just single circuit. This is three circuits connected together to make the three-phase circuit. Now here's the thing. If you have three loads, and you have three sources, AC sources, voltage sources, and you want to connect them, each source to one load. So you're going to have a source supplying a load, then another source supplying a load, then a third source supplying a third load. This is called single phase, and single phase. If you look here, in between, and this is one here. You just put it in different color. And there is another one here. So this sources, this here, the loads, three of them. The one in between that takes the power from the generator or the source to the load, we call it transmission lines. So those are the lines, transmission lines. They transfer the power from here to here. So each one of these, this is one single phase, and single phase. How many lines do we have? We have 6 lines. How many sources we have here? We have 3 sources. How many loads we have here? 3 loads. So to transfer the power from the source to the load, here we need 6 lines. This is called single phase systems. This is one single phase, this is one single phase, one single phase. Now define the way that is better than this, and we will show you in details later. Say, okay, here's what we have. These 2 loads, I'm gonna connect them in a way together to give me one load. It's called 3-phase load. So those 3 loads, I'm gonna connect them together. These sources, I'm gonna connect them together to get the 3-phase sources and become one source here. The 3 sources, they become one source. In between the lines, they said, okay, I only need 3 lines now. When I have this connection and this connection, this is 3-phase system. So how many lines I have here? In between, I have 3 lines. Now here's the good thing about the 3-phase system. One of the main good things. If you have single phase and you have 3 loads, you need 6 lines. One is the, the live wire, and one is the neutral, like the current goes and come back. But if you have three-phase system, you only want 3 lines to supply 3 loads, and we will see later how. But for now, this is what happens. Now, if you look around to the, for example, the system is here in Qatar or anywhere else, you're gonna see that before the electricity reaches your house, it's 3-phase. Why is 3-phase? Because Kahrama, for example, when they generate the power, okay, they don't want to put 6 wires, they put only 3 wires. They transfer the power to a place close to your house, the substation, and from the substation it goes to different houses. Okay. The idea here, I only need 3 wires, not 6 wires. So I'm saving money because I'm not using 6 wires. I'm saving on efficiency because I don't lose a lot of power in the transmission lines. I only have 3 wires. And if I'm going to use this system and this system to do the same thing, I'm going to lose more materials here, okay? I'm going to lose more material. And if I'm actually going to use 3 wires to do the same as those 6 wires, okay, to do the same as those 6 wires, basically even the current will be less, so efficiency is going to be higher. Anyhow, 3-phase system is better than single-phase system. Okay, you don't need more wires, the loads are connected together, the sources are connected together. There is another thing, the reason that we use the 3-phase system. Now the concept of generators, so the generator is basically like this. This is what is the generator. There is a magnetic field here. This magnetic field rotates, called the rotor. So this is north-south magnetic field. Now it doesn't have to be this way, but just as the basic thing. And you have coils here on the stator. Because there is magnetic field rotating, it's going to cross those coils, it will generate voltage. Okay. So this is the concept of generator. So a generator basically is a rotor like this that has coil on it. So if you put one coil, you're going to get 1 voltage. If you put one coil, let's say that this is the rotor, and you put one coil. The coil is like coming here, going around, then coming, leaving here. And there is a magnetic field around this coil, and this magnetic field is generated by another coil, or okay, and there is a rotation, which is a mechanical energy. You're gonna get the voltage. This is how we generate voltage. Now, you're gonna do, some of you is gonna do the motor generator course, so you're gonna see details of this. But the concept that we put a coil in rotating magnetic field. Coil, and coil is just an inductor. In magnetic field, north and south, there is a magnetic field, and this magnetic field has to be rotating or changing, so this coil will have an AC voltage. So magnetic field around this is going to give me a voltage induced in the coil. Now if you put one coil, you're going to get 1 voltage, but if you put 3 different coils, okay, one is this one, let's say, one is this one, and a third one is this one here. This is a coil, this is a coil, and that is a coil. 3 of them. How many voltages you're gonna get? 3 voltages. Okay. So a generator, if I get put 3 voltages, 3 coils, I'm gonna get 3 voltages. Those voltages, if the coils are the same, the magnetic field inside is the same, those voltages will be the same in magnitude. If this is 120, this will be 120, this will be 123 voltages I can generate. You can generate even more, but later we will see that 3 is okay, but 4 maybe is not okay, 5 is not okay, for a reason that you want a balanced system. Now this might sound quite difficult, but let's try to make it easier a little bit. Now these three voltages, you're gonna put a coil here. Let's say a coil here and a coil here. So what will happen? If the voltage here has an angle 0, this voltage will be different in angle because they're not at the same position. So when the magnetic field is here, it will take some time, so it will be there at the same point, then it will take some point to be there. Now if the magnetic here is peak, it's not peak here, it is because it's an AC magnetic field. If the magnetic here is 0, this magnetic field maybe is high, maybe this is low, so it depends on the magnetic field rotating. Okay? So sometimes this is where the first coil is, this is where the second coil is, maybe this is where the third coil is. Okay? So they're not gonna see the same thing. So what happens here, it will take about 120 degree will happen here. 120 degree will happen here. The point that we're looking for, that if the first voltage has an angle of 0, the other one will have 120, the third one will have 240. Or maybe the first one 10, the second one is gonna be the 240, the third one is gonna 120. But the difference between them, because they're located on full circle, the difference between the three coils, the degrees, is 120 degree. Now what we want to learn from here, AC power, the voltage when it's generated from the generator, it will give you a three-phase system. So one is called V, voltage at A, maybe voltage at B, voltage at C. The difference between this and this is 120 degree in phase angle, and between here and here is 120 degree, and between here and here is 120 degree. So if this is angle 0, maybe this one will be plus 120 or minus 120. So maybe it's 120 plus or minus 120. Those are the two options you have. This one here, so maybe it's plus 120 or minus 120. Now minus 120 means 240. This is angle 0. This is minus 120. This is plus 120. So this is plus 120. This is minus 120. This, if you go from this side, the minus 120 is actually exactly like a plus 240. If you go this direction is positive, and this direction is negative. Introduction kind of so confusing because part of it that you did not actually study generators. If you study generators, you will see why exactly we have this 120, why it can be positive, it can be negative, why we use three-phase instead of single phase. But I'm gonna give you an introduction to this, and that's basically it. Now I'm gonna go to the lecture, and hopefully when you see the lecture, you're gonna actually think this is not as bad as it seems to be. Okay. So, three-phase theory. So what is the three-phase? Okay. To the introduction here. Let's read what we have and try to explain it. There are multi-phase or polyphase, more than one phase generators. This is what we have actually in the industry. The power most of the time is generated by three-phase generators. Those generators, those sources, they give you AC, okay, more than one wave. What does that mean? The AC will give you one, will give you another one, will give you a third one, maybe will give you more than that. Fourth one, whatever, fifth one, so many AC. Now this is the AC voltage. This is one single phase. Okay. The frequency depends on the rotation of the generator. Okay. There are other generators that they give you single phase, not common. Those ones are not common, which is gonna give you only one wave. This is an AC voltage. The generator is gonna give you that. The reason that you have it AC like that, because there is magnetic field rotates, and when the magnetic field hit the coil at the peak, you're gonna get the peak voltage. When the magnetic field is hit the coil with a zero change, you're gonna get zero voltage here. So sometimes the magnetic field will actually be high, and sometimes it will be zero when it actually crosses the coil. So if it's crossing the coil at the maximum change, then you get maximum voltage. A bit more here. Here is a generator, and this is a three-phase generator. It has 3 coils. If you look at those coils, it will be in a position between them is 120 degree. Now, if this is A, this is B, this is C, those are the 3 coils. Between A and B, there is 120. Between B and C, there is 120. Between C and A, there is 120. The order, sometimes it's A, B, C, and sometimes it's A, C, A. Depends on how you put them. You can say this is A, this is B, this is C, okay? And the rotation is going like this, so A, then B, then C. But if the rotation is the other way around, like this, comes A, then C, then B. Okay, so these 2 different kind of, you can rotate the coils in 2 different ways. Anyhow, those coils are inside the generator. You have the terminals, the terminal A, the terminal B, the terminal C, and sometimes it has something at the 4th terminal called the neutral. And we will see when we have that and when we don't have that. Okay, so what we understand so far, 3-phase generators has 3 coils placed 120 degree apart. Okay, if 3 coils are identical, the generator is gonna give you voltages that is identical, but those voltages they're gonna have a phase angle between them, which is 120 degree, because they are placed apart by 120 degree. So each coil is gonna generate a voltage. Each coil is gonna generate a voltage. The coil A is gonna generate a voltage. The coil B is gonna generate a voltage. The coil C is gonna generate a voltage. What is the difference between them? They are exactly the same shape, the same magnitude, the same RMS value, but there is a phase shift between them is 120. So between this guy here, there's 0, and this guy is 120 degrees. So this is 120. Then the other one, there's 120 before the other one actually is at the 0. Then there is a 120 for the first one, then 120 to the second one, 120 to the third one, okay? So 3-phase generator is going to actually have 3 voltages. Each voltage has the same magnitude as the other ones, but they are different in phase. So what does that mean? For example, VA, the magnitude is 10. Angle, let's say 0. VB, what is the magnitude? It's going to be the same. Or the RMS value here, the RMS value. VC is going to be the same. But this is the magnitude, here is the RMS value. Okay. But the angle is going to be different. Maybe this is minus 120, and this is minus 240. In another way, minus 240, I can write it as 10 angle 120. Those are called 3-phase voltages. Phase A, phase B, phase C. They're generated in the same generator. They have the same magnitude because the coils are identical and the field inside is the same. But because they're placed at different locations, they're going to have different phase shift. So when the first one starts, It's not exactly when the second one starts. So we'll take 120 degree of time until actually the second one starts. So phasors, these are the waves, the three waves. The phasors will look like this. This is A, this is B, this is B, this is C. Okay, A, B, C. It means if they rotate this way, A comes first, then B behind it, then C behind it. So this sequence is A, B, C. It means A will come first, B will become that, then C. Okay. Those are the values, the angles. If you add these three, 10 angle 0 plus 10 minus 120 plus 10 angle 120, which is minus 240. If you add these three, it's going to be 0. Because one is going this way, one is going that way, one is going that way. If you add the three vectors, you're going to have 0. So we learn 3 or 4 things here. This is the start. Okay, this is the start. We learn 3-phase generator is going to generate 3 phases, 3 voltages. Those voltages will have the same magnitude, but they will have different angles. If I add those 3 voltages together, they're going to give me 0 because they're in different directions. So the total here, if you have 3 forces, one is going this way and one is going this way and one's going this way, they will cancel out each other. You can try it. You can plug, values, and you can try it. You're going to get the 0. Now, this is just a little bit of details about the generator. Look at, this is the magnetic field that rotates. This is the coils. Now with the coil this is here. The coil comes from this point, goes all around and comes back at some point. This is what we call coil. So this is for example, where the coils comes, and this is where the coils leaves. This is coil C, and this is coil B, comes here and leaves here. Coil A. The difference between the coils, look at A, B, and C is 120 degree. So A first, B, and C, the voltages, because magnetic field will rotate. So when the magnetic field is hitting this at the peak, it will take 120 degree until hits this at its peak. Then 120 degree will hit this at its peak, and it's like that. But if the magnetic field rotates the other way, A, then C, then B. There are 2 options. Magnetic field rotates A, B, C, so it's going this way. Or if it's going the other way around, it's gonna hit A, then C, then B. So you have 2 sequences here. You call them sequences, A, B, C, or A, C, B. There are lots of advantages for this. The 3-phase, as we said, we're gonna use less wires. Okay, that is gonna save you money, less maintenance, easier to install. Okay, and there is one quality that actually 3-phase motors and generators run smoother, because the magnetic field you generate when you have 3-phase, the total magnetic field you're gonna have inside is gonna rotate. The sum is gonna rotate. That is something that you're gonna learn if you do motors. The guys in electrical and instrumentation will do motors. I don't know if the telecom are going to do the motors, but when you do motors, you will see that running the 3-phase motors are way easier than running the single-phase motor. Anyhow, the point, 3-phase systems are preferred over single-phase systems. There are lots of reasons. We did say a few of them. Here's another thing to explain the 3 phases. This is 3 single-phase system. You need 6 wires. the three-phase system, this is three-phase source, this is three-phase load. You only need 3 wires. Sometimes we need a 4th wire, we call it neutral. That's what we need sometimes, not all the time. So maximum 4 wires. So you're saving on wires. Okay. Later we will see that the power here in the three-phase system is the average power is actually constant. The instantaneous power is constant. Here the instantaneous power is not constant. Okay. And if the system is balanced, the neutral current is 0. What does that mean? The current going here is 10 angle 0. The current going here, it's not going to be 10 angle 0. It's going to be 10 angle 120 or minus 120. Then the current going here, 10, 120. The 3 currents, they're going to hit the loads. They're going to meet together and go in the neutral. But when you add these 3 values, they will give you 0. So nothing is going to go through the neutral. So there is no losses in the neutral, basically, if the system, what we call it, balanced. Too much information. At the end of the lecture, we're going to actually see what we want to learn. There are a few things that you will learn later in other courses, but what we want to learn. So we said depends on the rotation of the magnetic field, depends on the positions of the 3 coils. We are going to have 2 sequences. We call them phase sequence because phase A, phase B, phase C. Those phases in which way, so if after, this is the voltage VA. What comes after VA tells you the sequence. If you see after 120, you see VB. Then after that, you see VC after another 120. In this case, this sequence is called VA. So the sequence is called ABC. Means VA, then VB, then VC. This sequence is called ABC. This means A, first angle, whatever the angle for A. B will be after 120. C will come after 240. Minus 240 is plus 120. This is called Bell's diff sequence. We're gonna go rotate this way. A, B, C. A comes, then B comes, then C comes after. This sequence is called ABC sequence, phase sequence. Okay, who's gonna come after A? Who's gonna come after? Yes, after A. Then who's going to come after that? Now there is another option you can have. You can have VA. Okay, and by the way, it continues. Okay. Then what comes after A? You see actually VC. Okay, that's possible. If you put A here, for example, and you put B here, and you put C here, and rotates this way, you're gonna see A, C, B. If you put them in another way, you put A here, C here, B here, and the rotates is this way. So you're gonna see A, then B, then C. So then the third one will be in this case B. This is, in this case, this sequence is ACP and called negative sequence. So 2 different sequences, A, BC, and ACB. Now, if you have the 3 wires, A, BC. If you flip any two wires, you're gonna have the reverse, which is A, B, C, CB. If you flip any wires, okay, if you flip any wires, flip any two wires. So when you change the sequence, you're gonna change the rotation of the magnetic field, basically. Okay, change the rotation, change the magnetic fields. In motors and generators, when you change the sequence, you're gonna see a rotation in a different direction. So for example, a motor has this three wires. You supply it with A, B, C, it's gonna rotate, let's say this way. This is where the motor will rotate. Then you, the same motor has three wires. You supply it with A here, and you connect C here and B here, for example, it's gonna rotate in the other way around. And if it's a motor, the same motor has the three wires, and you supply it here with B and A and C here, it's gonna rotate in this direction, opposite of this. Because this is basically A, C, B. You go A, C, B. What's after A is the C. This is just to explain the sequence. The sequence, basically, the phasors rotate this way. The phasors rotate this way. So if you're here, what is coming after? B. Then what is coming after that? C. Now this is anti-clockwise, the rotation of the sequences. And makes sense. The sequence, this is the phase. This is angle 0. Then goes to the 90. Goes to the 180. Goes to 270. Goes to the 360, which is 0. So basically the wave starts from 0. Goes to the 90. Goes to 180. Goes to 270. Then goes back to 0. This is the rotation. This is where the wave is rotating. So if you're standing here, you're gonna be, okay, I see A. Then what comes after is gonna be B. Then what comes after that, because the phases are rotating like that. This is A. Then this is B. It rotates the same way. It goes from 0 to 90, then but comes after A. Then C comes after B. So this sequence is called the positive sequence, and this, the opposite sequence, when you see C here, called negative sequence. So in the positive sequence, if A is 0, B is negative 120, C is negative 240 or plus 120. If it's negative sequence, it's the other way around. C will be the minus 120, B will be the plus 120. Now we get to exercises, and in exercises, you're gonna start to learn this. Here is what we have. 3 phases, 3 voltages, okay? They have the same magnitude. So they're basically coming from the same generator. Then there's angles in between. So the angle here is 10. The angle here is minus 230. Sorry, 230. The phase angle here is minus 110. The question is, what is the sequence here? Is it A, B, C, or it's A, C, B? So how do I do this? I take the A. This is the angle of the phase A. It's 10. If I subtract 120, so minus 120, where I go, the one behind it, it's going to be minus 110, right? 10 minus 120 is minus 110. The question you ask yourself, is this C or B? You see it's C. So basically, the second one comes after this is theta C, which is minus 120, 110. Then you're going to subtract another 120. What you're going to see the angle for the B, which is minus 230. So look at the A, subtract 120. Which one is that? C. So you put C. Then subtract 120. Which one is that? It's B. Okay, so this is the theta as B. This is the theta A. And this is the theta of the phase C, the phase angles. So when I subtract 120 from A, I got C. When I subtract 120 from C, I got B. That means this sequence is actually A, C, B. So it is the negative sequence. We call it negative sequence. It just means opposite of the other one. Is this okay? The concept here of that three phases, the phase difference between them is 120. The first one is A, then the second one is minus 120, so behind it by 120. Then the third one is behind the second one by 120. Any questions here? The introduction for this is a bit difficult. Even with the time, it will be actually easy. You will be looking at the phases and stuff later, and you will be like, this is not difficult to do. Any questions? Okay. Here's another question. We will stop here, okay? Exercise 2. Okay, and here, they give you the phase A, phase B, sorry. So you have three things. They say positive sequence. What does that mean? A, then B, then C. They say you have a positive sequence, means A, B, C. They give you the voltage here, VB, N, 120, angle 60. They say find VA and find VC. Now, we know that if the system is balanced, the voltage is for all of them is the same. So it's going to be 120, 120. The angle, so the angle here is 60. The angle here is theta. Here is 60, theta A. And here's theta C. Now if we subtract theta A minus 120, should give me 60. If I subtract minus 120, it should give me theta C. So 60 minus 120, the angle here is minus 60. Right? 60 minus 120 is minus 60. So this is minus 60. But what's the angle here? Why is the angle that if I subtract 120, it will give me the 60? 180, yes. So it's 180 here. Because 180 minus 120 gives me the 60. So you can go the other way by adding. If you go this way, you're going to add. Because that is ahead of this. If you go this way, you're going to subtract. So a few things that we learned today. There's three-phase system. Generators that will generate 3 voltages. Those voltages will have the same voltage, the magnitude, but the angle will be different. Those 3 voltages, I can put them in 2 sequences. What comes after A? If it's C, then it's A, C, B. If it's B, then it's A, B, C. Two options you have. Every phase to the next phase, there is 120 degree. A, then the one after it, minus 120 degree. Then the one after that, minus another 120 degree. Is this okay? Any questions? Recommendation at the end of this, that we are, it would be a good idea to watch videos on three-phase theory, just the introduction, three-phase generators, sequences, phases. Some videos will actually show you a few good, interesting stuff. It might help you to understand the concept more. Okay, people who are gonna go into the three-phase generators and motors, the course MP1200, those students will see how we actually generate this. Those who are gonna go into telecommunication, I'm not sure that you will use much of the three-phase analysis. So maybe for you guys in telecommunication, three-phase analysis is not as, unless you use motors for some applications. I'm gonna actually stop here. So we did up to the 12, and this was my goal, to reach 12. So next time we can finish this lecture. I'll take the attendance, then I'll let you go. So today is the 27th. Okay, quickly, I'm gonna call the names. Okay, if you're around, just say you're here. Abdullah Khalid. Muhammad Mohsen. Hassan. Abu Hassan. Rand.
Yes.
Thank you. Yazan. Sarah. Abdullah Ali. Maryam. Maryam Ahmed. Abdullah Ahmed.
Yes, sir.
Ahmed Al-Tayyib. Khalid. Ali. Asma. Muhammad Yusuf.
Yes.
Lean. Fahad, yes. Amal. Abdullah Hassan. Hazim.
Yes.
Samar.
Yes, sir.
Thank you. Ziyad. Awatif. Sam.
Yes, sir.
Manal.
Yes, sir.
Hamad.
Yes, sir.
Asia, sorry. Sharif. And Ahmed Ayman. Okay. Thank you, and I'll see you inshallah next week. Remember, the